Welcome to another episode of Xa Talk Show. Today we are going to do emacs lisp coding. Fantastic emacs lisp coding. And so we are going to write a function, a command. Actually, I already wrote it, but I'm going to do some alternative algorithm. So we are going to write the emacs command that inserts random characters. Okay, so let me show you. Okay, so open a new buffer. On the pink window, you can see all my keystrokes and command calls. You can see the function name. Hold on a second. So let's turn on highlight the current line so you can see where my line cursor is. So you can see all the function names and all the keystrokes I type. And I'm using a Kinesis Advantage keyboard right here. And this is Ultimate Hacking Keyboard. You can go to my website and see the review, okay? Xali keyboard. Kinesis, okay, for example. So you can see Kinesis Freestyle keyboard. This is a good one, I recommend. And ergonomic keyboards, and you can see my reviews of my keyboards and Ultimate Hacking here, okay? So that's about keyboard. So let's show, okay, so for example, something, okay, so I want to insert a random string, okay, do it, you see, there it is, okay, do it, another random string, do it. So the command I'm calling is this one, okay, xa insert random string, and here's a code. Oh, actually, you can see the code. So let's go to the source code, and here is the URL, and open the URL and show in browser, so you can grab the code there. Okay, so we have several commands to insert random number. You can insert a random number. Let me show you. Okay, so go to Xa's Talk Show today, Xa Talk Show today, and let's paste in the link. Okay. So you can later on you can go to the website. So so let me show you the several different ones. Okay, insert a random number. Insert a random number, 3 digits. Okay, if you want more than 3 digits, you can say Control U, then call the command. Oh, that doesn't support Control U. Wait, does it? No, it doesn't. It used to. So anyway, so that's the command. Okay, so let's go to the source code again. So let's see, where is the source code? Okay, so xa insert random string, xa insert random number. Okay, it no longer takes a arbitrary, allows you to insert. Yeah. Okay, this is about design. Okay, so we are writing a command that insert random number of digits, and usually in Emacs you can write the command such that Control U, then call the command, then you'll provide alternative parameters like how many characters, how many digits you want to insert. But in my case, I removed that because I thought, just call it again every time you add three random numbers. Okay, so that's the insert random number, then insert random kind of string, kind of. Then you can also have insert random hexadecimal. Okay, so here is a hexadecimal. Call it again. Do it again. Hey, what? Okay, xa insert random hex. Okay, do it again. Do it again. And do it again. Do it again. Do it again. Random hexadecimal. You can see there is no. It's 0 to 9 and A to F. That's hexadecimal. Okay, so we are going to write a command. So we are going to. So that's hexadecimal. So you have insert random numbers. You have insert random hexadecimals. Then you have insert random string. So then you started to see Q and W and capital Y. And in this command, let's see, Control U and do it again. Oh, it doesn't support the universe. I think I removed it. Anyway, so insert different random digits or strings. This is useful. For example, when you are in HTML, in programming, often you want to insert, like for ID purposes, like a random ID for a tag or for and also, by the way, you also have insert random uuid. Okay, uuid. So insert random uuid. Uuid is this huge thing. You can look it up, Wikipedia. UUID. That's a basically universal random string, something like that. Supposedly, the possibilities there are more than the number of atoms in the universe. It is true, a lot more than that. So supposedly, for any function, for example, especially Microsoft use this often. If you are using Microsoft, you go to your home directory, you can see, some files named like that. Microsoft use this UUID often, and also in a game Second Life, the virtual reality. Am I doing good? Say hi, guys. Okay. Oh, okay. 2 people watching. So insert random number. So UUID. So we have a bunch of them, and today we are going to recode this. Okay. So let's begin. So let's cut that. Let's go back to the talk show, and let's put it here. So we have a record of what we pasted them. Okay, so you can see kind of random numbers. Okay, so now we want to modify the code. Okay, so let's begin. Okay, so let's show the code. So what this do, what the current implementation is that, okay, so it inserts any of these random characters. Okay, you actually predefine them, and this bunch of random numbers include A to Z, 0 to 9, except no vowels. So there's no A, no E, no I, no O, I. Okay, so no A, E, I, O, no U, and also there's no 1, there's no capital, there's no O, there's no capital O, 0 neither, and there's no 0. So you can see, because these characters are confusing, and there's no capital I or L, lowercase l, and actually I don't think I include L at all, because you cannot see it here. So you start by defining a string that's a character set. Then you define a base count. Base count is what? Is how many characters you want. Yeah, count x, something like base count length character set. No, that's how long is this string? That's base. You consider that as number base. For example, for hexadecimals, the base is 16, because there are 16 different possible symbols. Now in this case, the length of that is the base count. Okay, so that's the base count here. Then you have count x, which is how many times you want to insert. Now, okay, so now so today I just had a whim, kind of. I thought of, why don't I rewrite this, because this is not this is very fast, efficiently, fast enough, like you won't be able to see how delays. But however, I'm thinking using a different algorithm, which is based on ASCII characters. Let's just do it. Okay, so anyway, so once we know the number of the length of the string and how many digits we want to insert, then we just insert. In Emacs, you just do that many times, and each time you insert, pick from an element from the character set, then you do a random, you pick a random letter. So that's how this code works. Okay, so now we want a different algorithm. So let's put it here. So insert random 2, let's just name it that, okay? And insert okay, let's do, oh yeah, you see this line, this documentation is actually incorrect because I removed that, I think. Wait, yeah, I think I moved. Anyway, so I want to write a new one, okay? So let's begin fresh, okay? So let's delete the whole thing. So we are going to write this new command with a different implementation. So first of all, it's going to just insert any one of the let's write it out, okay? Insert any of A to Z, and 0 to 9. Insert any one of those characters, okay? Remove that and put the version date, okay? Now let's let's start. So you know, so let me show you another thing, okay? So you see the reason this algorithm is not super efficient, comparatively speaking, is because, you know, if you want 5 digits, you have to do times. You are doing it 5 times. Each time you pick a random character from this char set, you know, you have to do it 5 times. Now, as opposed to, for example, there is, for example, let's write a insert hex, okay, hexadecimal. And in this case, you can just say insert, okay, random, okay, a random number. Let's say random number that, let's say that 1 million or something, okay, and you want to format it, okay. So you want to turn the number into a hexadecimal. There's a built-in function, format, okay. So format, the % x will be hexadecimal, I think, I'm pretty sure. Then you just put this random number there, so that, okay. So this command, okay, this function now will insert a random hexadecimal, okay. Let's evaluate it, okay. Now let's call it, let's call it, call insert hex, do it, you see, there it is. Call it, 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 there it is. So in this algorithm, you can see it only calls the random function 1 time. You know, the whole thing, it doesn't matter how many digits. Let's try more digits, okay? Wait. Let's increase the randomness, you know, 10 million gazillion, okay? Let's evaluate the code. And let's do it. Call it. You see, call it, call it, call it, call it, call it, call it. You see, now the hexadecimal is much longer, but however, it's still one shot, you know, one random number. So this is what I want. You know, I feel like, you know, doing this instead of going through the alphabet, you know, pick a number and do that multiple times. Okay, so now, okay, but you see, so this algorithm is insert hexadecimal. So there's a built-in format that converts a number, a decimal number, an integer to the hexadecimal, okay? But there's no, but if you want to insert, you know, any A to Z, you want a number base, basically that's number base of 36. So it's, each digit would be 0 to 9. And A to Z, okay, it's more than, you know, for example, 0 to 9. Then A to Z, and also capital A to Z. So how many total of that is, you know, that's 26, that's 26, that's 52. So there's 62. So you need, you are having a 62 based number system. But however, there's no built-in command to do that. Okay, there is in Wolfram language actually. Let me show you. Okay, a bit digression because nobody is here watching my stuff. Oh, fantastic! Fantastic! Thank you guys. Oh, Flamio, thank you for being my loyal patron. You can prove this wasn't a random number. That's correct. And I want to ask, what way do you recommend to dump emacs Lisp data structures like records to the screen for debugging usage? I'm not sure what you mean actually exactly. So explain, okay. So you want to ask me what do you recommend to dump emacs Lisp data structures like records to the string to the screen for debugging usage. Okay, so in emacs, so let me maybe explain that, answer that. Okay, so you want to basically, so in emacs most syntax has a print. God, am I going to answer that or am I going to continue because I start to digress in multiple directions? Let me show the Wolfram thing first, okay? Yeah, so multiple ways. Which one to go first? Okay, so comments, okay? If okay, keep comments, okay? So let me show you the random number, okay? So random integer, okay? So there is a function random integer, and this is 11 to, let's say, a billion something, okay? So that's Wolfram language. What I'm going to show is that I'm going to show, normally in all languages, in C, C++, emacs Lisp, in Lisp. Okay, am I still alive? I think my computer froze. Yes, my computer froze caused by Wolfram language. God. But is my video, am I still streaming? Say something, guys. Okay, I think I'm still streaming. That's okay. Yeah, I had a hard freeze Wolfram language. That's because it's sucking up all the, I think it's sucking up all the memory. Okay, so now let's do it again. Okay, it shouldn't. I don't think there is a. Okay, what I want to show you is that now is that in all the languages, Java, JavaScript, Perl, Python, whatever languages, you have a function built in that turns a integer to a hexadecimal or octal number. Okay, for example, you can for example, let me demonstrate. Okay, so for example, I have this. Let's say, I can run it. I can run it, or that's a hexadecimal, okay? Or I can change it to O, then it'll insert a octal number. You see, octal number. Octal number is 0 to 8, basically, always 0 to 8. So hexadecimal, octal. But however, these languages doesn't, octal is 8, hexadecimal is 16. What about 15? I want a number system that converts a number integer to a 15 based number. What about it? You can do it. You have to write it yourself. What about 14? I want a 14 base system. You can do it. Because what? Do you know why? Because the C and Unix idiots, they made a condition to such a degree that the programmers don't even know what is base 14 means. But Wolfram language does. Okay, let me show you. So let's say random number 1 to 10. Okay, so that's it gives you do you know why we had a crash before? Because I was asking Wolfram language to return like 1 billion a list of 1 billion items. So that's why it's eating up all the memory. That's why my computer froze. It didn't crash, but so yeah, that's why. So but if you want to random number from 1 to 100, that's what you do. Okay, so you can see so you see 51 or you can actually do a table. Let me show you a table of random numbers 1 to 100 and how many times. Let's say 100 times, let's say 10 times. Okay, you see now so I want to demonstrate Wolfram language where it converts a number to any number base system you want. Okay, so how do you find the function? You type base. Okay, I don't remember the function name offhand, so you type base and let's say base encode, baseline position, base number base. Okay, something about number base. Base form. Okay, open it. Exactly, that's what we want. Base form. Okay, so let's do it. So base form. Okay, so what is the syntax? I believe we just let's say 100 base 2. Let's say 10 base 2. Okay, yeah, that's what it is. Okay, so let's say 10 base 3. There it is, you see, and you can see the subscript. Okay, fantastic. Now let's say base 16. Okay, 10 in base 16, that's A, subscript 16. Okay, now what if you want 100 base 16? Okay, that's 64. Okay, now if you want what if I want base 17? There it is. Okay, now what if I want base 50? Okay, requested base 50 should be an integer between 2 and 36. Okay, so it doesn't have 50. so let's do 36. Maximum base is 36. Why? Because it uses the the alphabet A to Z in addition to 0 to 1. So you got 36 base, 36 distinct symbols. But if you want more base than that, then you have the question of what symbols you're gonna use. So by default it's just base 16. Okay, so now we can do a random integer. Okay, random integer of 1 to 1 million or something. Okay, base 36. Okay, let's try it again. So you started to see okay, the number is not big enough. Let's say big. Okay, so so that's what we want. You see, that is actually what the function we are trying to write. In Wolfram language is basically just one single line. Okay, that's Wolfram language. So that's what we are trying to do today. So okay. So now I finished demonstrating Wolfram language. Let's go back. Okay, and let me go back to the base 64. Okay, that's a special case, and Wolfram language has that. Okay, let me show you. And Emacs also has that. Okay, so I believe, yeah, base 64 decode encode. Okay, so base 64 encode region. Okay, so for example, you want to encode that to base 64, and you just call base64 encode region. There it is. Okay, now base64 is a special case. It's because it's often used. Okay, you can look up Wikipedia. Basically, it uses all the alphabets, including capital case and including, I believe, also includes some punctuation symbols. But that's a special case. So in Wolfram language, you also have that. So what is the function name? Base encode. There it is. This one. Base encode. B encodes the byte array BA as a base64 string. Okay, so base encode. So you want byte array. Okay, so what byte array? So let's give this the same string here, but except you cannot have the double quote because you have to escape the double quote. Okay, so the whole thing will be a string. There it is. So we're gonna wait, you need also double quote, escape there. Okay, so the whole thing will be a string in Wolfram language. Okay, so let's paste it here. You know, we are encoding a emacs lisp function in Wolfram language. Do it. Okay, so wait, my syntax is wrong. So it doesn't take a string. Okay, so let's look up the documentation. So encodes the byte array BA. So it requires a byte array. So there is also base85 ASCII. Okay, so you need a byte array. So it doesn't take string. So you need to, I believe byte array can convert a string to bytes. Okay. Now let's try again. Yeah, how do you convert a string to byte array? String to byte array. Everything must be very formal. So you have to say string to byte array. Okay. Okay, let's do that. It's a string to byte array. Paste it. Okay. Did we match everything correctly? Yes. What? Yeah, what's going on? Oh, I copied it incorrectly. God. You know, that's because of the formatting thing. Okay, so because you see the Wolfram language is actually hidden, it's doing that. So we actually just want that. Okay, so delete the hidden thing, just that. Okay, fantastic. Now let's verify. So KGR1ZN. There it is. KGR1ZN and ends at KSKK. Oh, the ending is different because we got some line return. Let's do it again. Okay, copy it, paste it here. Now select this carefully. Now call base64 encode region. There it is, KSK. Wait, why does it not ending the same? Wait, when did it start to differ? DAWMDA, so DAWMDA, okay? Then WMCKPK. Okay, so the last 3 digits differ because, well, probably because of the line return. Anyway, yeah, I don't want to spend time to figure out, some line return characters at the end. Okay, so that's about that. Now let me address the question. Okay, the question about how do you dump the emacs lisp data? Emacs lisp data, for example, you have a vector to usually you evaluate it, you can see that's the output, so you don't actually need to dump anything. So because what you see is what you get. So that applies for array, that applies for a list. For a list you can see now. But you are talking about a record. So for certain emacs lisp data structure, there is no printout form. For example, let's go to emacs lisp, okay, tutorial, and let's look at hash table. Okay, so emacs lisp has a hash table, and you can make a hash table like that. Okay, let's copy that. So let's hash table. Okay, so let's, where are we? Where do we do it here? Okay, so let's start a new one here. So hash table. So here you create a hash table, evaluate it. Okay, let's show the pink window. Evaluate that, then you describe variable my hash. Okay, wait, why is it not? Evaluate, then describe variable my hash, and you can see what? Wait, set q my hash, evaluate it. Okay, then what is evaluate my hash? There it is. Okay, so here is what it returns. So that is the printed representation of the hash table. It begins with a pound sign and s, then hash table, then whatever. So this is a special case for certain data structures in emacs lisp, when there is a when there is no read syntax for it. But in the case of hash table, actually you do have a read syntax for it. But anyway, that's so you are seeing it. Okay, so let's go back. Okay, so let's add some items into the hash table. So put hash. Okay, let's copy that. So we're gonna add some hash, evaluate it, then we want to know the value of my hash, evaluate it. Okay, so you can see at the bottom, there it is. So you can see the Joe 19, that's one entry of the hash table. So that's a read. That prints the read syntax that represents the hash table. Okay, now, but you are talking about record. Okay, I actually don't know about the record data structure. Now, a record data structure in emacs lisp is like a vector, which is like a tuple of Python. Okay, it's like a vector, but each element can be different type from other elements, so they don't all have to be the same type. So in emacs lisp vector, every element must be the same type. No, in emacs lisp vector, every element can be a different type. For example, this works. But a record is such that, I haven't used emacs lisp record before, so actually I do not know your answer in particular if you are asking about vector. So comments, okay? Comments based on what I just said, if you still have a question or not. Okay, so let me read other comments. I have to work with Java at my new job, still pay the bills. Indeed, Java and C++ and Golang and Python. Okay, so what is Wolfram language based on? Does it use JIT or is it completely interpreted? Either way, okay, so you can, but usually you would say it's just interpreted. Okay, you cannot, it's not a language where like C or Java where you have to, or Golang or Rust where you have to almost compile into a compiled object, then you can run it. But you cannot do that, generally speaking. Okay. So anyway, that's it. So white space. What do you mean white space? I don't know what you mean by white space. So okay. Anyway, how long have we been going? 40 minutes. Okay. So now what do we do? Do we continue to write this? Yeah. Let's continue to write this function. Then it's okay. So let's do some cleanup first, okay? So let's go to talk show, and today's talk show, and we talked about we talked about base 64. Okay, so let's do it. Okay. Base 64 encoding. So let's copy that, okay, put it here. Then base 60 encoding of Wolfram language, let's also copy that, which is this code. Okay, so that's good. That's Wolfram language base 64 encoding. Okay, I'm gonna show you in a moment. So let me just clean up here. So that's emacs lisp. This is what that's the command you do. Base encoding something. Okay. And okay, so let me move here so you can see it. And okay, so what this is a bunch of random numbers. Then we talked about the representation of emacs lisp data structure, printed representation. Okay, so that's this part. Wait, yeah, that's this part. So let's put it here. Okay, and syntax color the whole thing. So this is what we talked about today. Base and arbitrary number base. Okay, so we also talked about arbitrary number base. So let me show that. Let me put it in the here. So that's Wolfram language. Okay, so we talked about, we showed some emacs lisp code for doing, for generating random strings. We showed the built-in function format to convert a number to hexadecimal or octal. Okay, so and we okay, so now let's write a function with a different algorithm to convert to, yeah, let's quickly write that. I want to finish. Let's finish this instead of just wandering off. Okay, so I want to write a function. So insert write. Okay, so this is what we want to. That's a documentation, and we want to insert. Okay, insert something, and we want to A to Z. So first of all, what we need to do is ASCII numbers. Okay, so we look up my reference on ASCII characters because I need to know the range of characters. So if you want A to Z, so 0 to 9 is 48 to 64. Okay, so let's write here. So ASCII character is 48 to 64. what does that mean? For each character, there's an associated number, which is, you can think of it as the ID, identification number for each character. Okay, this same thing in Unicode. So usually this number is called the code point for that character. Okay, but usually the official terminology is code point. Yeah, but you can just think of it as a ID. Okay, the integer ID. So every character is associated with a integer ID. Okay, so for the digit 0 to 9, the ASCII characters, so that's 48 to 64. Okay, and for A to Z, so A begin with 65, and Z is 90. Okay, and the lowercase a start with 97 to Z 122. Okay, so 60. So how many total number of characters? Anyway, 26 total chars. Okay, so basically, so we want to generate a random number. Okay, so let's continue coding non-stop. Oh yeah, so yeah, I think that's because of the white space. When you get a big hash table or a record during runtime, it is hard to make sense of it. Maybe it's a record, maybe a hash table. Oh, okay. So in that case, you have to write a function basically so your question is, when you have a hash table in emacs lisp or a record. I never used record data structure anyway, but suppose hash table, if you have a hash table in emacs lisp and you want to print it, usually it's confusing. So in that case, you just have to write a function to print it each entry yourself. That's what I think that's what you are asking. That's what I do. In some languages, you have to do that. You have to do that in Golang. Okay, yeah, it's interesting. Let me show you Golang, because in some languages, turns out you need to do that. In other languages, you have a built-in function or library just to print arbitrary nested data structure. But usually in low-level languages such as Golang, you have to write that yourself. And in the case of emacs lisp, I think you also have to write that yourself. Yeah, because sometimes I do. Because, for example, let me show you Golang example first. Okay, so in Golang, you want to print slice. Okay, slice is a good example. A slice is basically like a list or array in other languages. Slice in Golang is basically a array that can change size. Okay, so it's flexible, can change size and change elements. And so where is it? Okay, so slice. So here you can see Golang tutorial on slice, and there it is. How do you print them? It's a problem. It's if you use the default it prints the whole thing in one long line. When you have 100 items, it's hard to read. So you want to print them one item at in each line. So you have to write a program. So there it is. This function print slice. Okay, that's a Golang example. Now in emacs lisp, I believe I also did similar for hash table. So here is a hash table. But sometimes you want to, if you just ask emacs to print it, it's one incomprehensible line. There it is, print hash table. Okay, so this function, it'll print them nicely, one entry per line. Okay, that's hash table. Okay, so so let's go to my tutorial. So let's put it here. Go to today's talk show. Okay, that's emacs lisp print hash table, and there is golang print slice. Okay, now let's finish this function. Okay, insert random number. So first of all, let's say insert 0 to 9, 48 to 64. So we want a random what is the limit 68 to, okay, so that's kind of annoying. So here generate the random number. Okay, so what you want to do is so let's define a function where 64 minus 48, so that is the digit range. Okay, that's the ASCII digit range. Okay, so now you want to, okay, so let me show you. Okay, so let me just code this. Okay, so let's start digit range start 48, digit range end 46, then digit range end minus start. Okay, so let's hold on a second. So I want all my variables to start with X. That's my personal convention. Okay, prettify the code. So digit range start end, then a low az range. Okay, okay, so low az range they begin at 72 97 122. Okay, 97 122. Okay, okay, now next cap. Okay, okay, capital case 65 to 90. Okay, 65 to 90, and okay, then we have minus. Okay, then we need a cap. Okay, okay, I think that's, my variable names are too long, but let's not worry about it. So we got a range. Let's say range digit start 60 48 64 end minus start. Okay, so this is reversed. Glad we found this. Okay, so low end az. Okay, so that's that. Okay, we got a range. So now we want to generate oh my god, how do you do this? Let's just start to generate. Okay, so x digit range, so that gives you a number plus you know, in emacs Lisp syntax, the nested paren, you cannot do arithmetics easily. So you want a random number plus the plus the start. Okay, so that will return, this line will return a random number between 48 to 64. Okay, and that in emacs Lisp a character is represented, the character data type. There's no character data type in emacs lisp. However, a character is represented by an integer of its code point. Okay, that's its ID. So therefore, this gives you a number between 48 to 64, and that represents a character. And then you can print it. You can convert the character to string. Okay, so let me show you. So char to string, yeah. So hold on a second. So let's declare a new random digit. Okay. Okay, so that's another new variable. Set random digit equals to that. Okay, so now we can char to string insert. Okay, clean up the code. So here is our code that just insert a random digit for now. Okay, let's evaluate it and let's call it. Okay, let's try it. Call it. Do it. Wrong number of argument, lambda count. Oh, okay, so we got, of course, we got the parameter. We don't need that parameter. Evaluate it. Okay, show the ping window. Call it. Do it. Call it. Do it. Symbols value as variable is void. Okay, so random digit, x digit range end. Okay, x digit range end. Symbols variable is void. What? So let's copy the here, copy it and search it. Make sure we don't have spelling errors. So why is it void? X digit range end. Okay. Okay. Why is it void? X digit range end. What is the error? What? Let's see. Where is the error? Let's call it again. Okay. So shrink the code, evaluate it, call it, do it. Symbols value as variable is void. X digit range end. Symbols value as variable is void. Oh, I understand. You see, because we are using let declaration here. In let declaration, any of the variables you declared here do not know the value of the variable you declared previously. So here we are calling x digit range end, which is defined here, but however it doesn't know, so you have to use let asterisk, so that will work. Okay, evaluate it, call it, do it. There it is. So there it is. Okay, so do it, do it, do it, do it, do it. Okay, wait, some of this is incorrect. It shouldn't insert a colon. But anyway, so this insert one character, that's correct. God, we need to fix our code. So it shouldn't insert a colon. So where is the ASCII? So let's double check our ASCII. So 02948 to 64. So let's see ASCII 48 to 257, not 64. Yeah, we got it wrong. So 257. Okay, so let's 57 is the correct. There it is. Okay, so we fixed that. Let's fix something else. Now, each time this, it generates a random number. How do we do this? You see that what I really want is to generate a huge random number only one time, only once. Then convert them into alphabets. But right now, our algorithm is not correct. Is not doing the right on the right path. So right now it's it's just generating one single digit. How do you okay, the problem is more than I thought. You cannot, if you only want call the random number only one time, if that is the restriction, and you want to turn that random number into into a 36 based number notation, it's easy to do. However, it's fairly inefficient, because then basically you have to do a loop n times looking up characters. Okay, so okay, so anything else? I think that's it for today. So that's 1 hour. I mean, so how do we solve this problem? Okay, so there's some change, as you code, you notice something. So if you really want to just code a random number only one time, then try to convert that number to, let's make it simple. Let's not include A to Z, let's just say A to Z, let's say all lowercase and 0 to 9. So you want to convert it to a 36 based number system, just like here, so like these examples. So in order to do that, yeah, you can do that. So okay, it's not so trivial. So one of the brainless way is just to build a lookup table like that, like a bunch of strings. Then you just take the position. Once you got a you process. So once you got a random. Well, yeah, so my thought is not complete. But anyway, one of the ways to do a lookup table, so you have to do it many times. That's not good. The other way is to, so you want to turn, so it's math-based approach. So you got a number, you got a huge number, you want to turn into a n-based numbering notation. Yeah, you can do that. But oh God. But again, yeah, but again you have the digit problem, because each time you got a number, you want to turn that into a digit, into a digit, which means one of the alphabet, one of the letters. How do you do that? There's no magical way. You have to either reference a reference a string or a vector or a list to get that actual digit. Then you have to do a concatenation of all the characters. Okay, so yeah, you can do that, but that's a different algorithm, but it's not more efficient than just this way. Yeah. So okay, I'm kind of so haircut is looking pretty good. Okay, I think that's it for me. I'm kind of at this point, you know, I'm wondering where should I go now. So let's make sure if we were correct. So if we want to only generate the random number one time, if that's the criteria, then what we need to do is really, it's pretty cumbersome. Yeah, because then you need to do a lot of powers computation to find out what is the number for each digit. Then do a lookup to convert that digit into one actual symbol, one of the letters. So that turns out, if you want to do that for the goal of generating a random string, that is actually much more inefficient than just that. Okay, so that, yeah, that idea is gone. But what are some other ideas such that you can generate a random string, but without doing a loop n times? How can you make this more efficient? Okay, I don't think there's a way, not, at least not in a high level language sense. I mean, if you are doing C, yeah, you can, use memory, bit dealing, bits, and you could do that. But from a high level algorithmic point of view, I don't think there is a more algorithmically efficient way, because ultimately you have to look up, if you want n digits, you have to look up n times. If you want 5 digits, you do have to look up 5 times eventually. Okay, that's my thought for now. I could be wrong. I think I'm pretty correct on that. That's it for today. Thank you guys for watching. Bye, guys. Okay, shutting down in 2 minutes. So this code, it generates a random number, then only converts to 1 digit. Yeah, that's not good. And also, this char to string function is fairly expensive. You don't want to call char to string n times. Is there some clever way? There's maybe there's some clever way of using the built-in format for hexadecimal. So you just double hexadecimal. Hexadecimal is 16 based. So if you double that, you have 32 based. But can you actually do that? Yeah. I'm not sure. Okay, bye.